So, good afternoon, everyone. I'm Nguyen, a software engineer in Google, and my other team members is Hung, who is a student in USF. So, our motivation for this project is because I believe that we are facing a fundamental problems in cybersecurity today: information overload. Security teams are drowning in data but starving for actionable intelligence. For example, in 2023 alone, over 25,000 new CVE were published. But how do we determine which one actually matters for a specific organizations? So this project has focused on using knowledge graph to transform the isolated data point into the interconnected database. With Nvidia and ArangoDB announced this challenge, I saw this is a really perfect opportunity to take this work to the next level. For me, the most pressing challenge I have observed is how do we prioritize our security effort in a landscape of an endless vulnerabilities and evolving threats, especially when we have an AI is evolving really hard. These are some business impacts that we if we don't care about cybersecurity is, for example, an average cost of a data breach is now like 4.45 millions per breach, and 82% of the breaches involving related to human elements, and organizations typically have resources to patch less than 10% of these vulnerability immediately. So this caused them a lot of business impacts when we go into cost of money, times, and maybe even worse, trust, like customer trust. So for our projects, we use the five different data sets. One is NVD vulnerability database. That is for comprehensive CVE records with technical details. MITRE common weakness enumerations, CWE, categorized software weaknesses. MITRE common attacks, pattern enumerations, documented attack patterns that happened already, and MITRE attack frameworks, the technique and tactics used by threat actors, and MITRE's database of threat groups and software, profile of no threat actors. So by integrating these datasets into a unified knowledge graph, we can trace the relationship between specific vulnerabilities and the threat actors more likely to exploit them. This is the graph model design that Hung and I coming up with. We will have a different data nodes with vulnerabilities, CWE, which is a weakness categories. For example, CWE 79, which means that cross-site scripting, attack patterns. How can you attack the cybersecurity network? Techniques, groups, and softwares. Uh, these along with these nodes, we will have some relationship amongst them, which is has weakness, part of the patterns, implements, can precedes, use techniques, use software, and exploits. So, for example, when processing with the CVE data, I extracted the CWE reference to create a hash weakness relationships. So then link those to attack patterns through the part of patterns edges. So let's go to our notebook. Import a data set into the graph with a lot of nodes. You can see there's a bunch of nodes that we are input into, and there's around more than 280 documents about vulnerabilities, more than 965 TWE, and more than that. As you can see, there's no edge count because we are still in process of creating the database. So after that, we will try to add the edge of the into the database. You can see that is having a lot of edges, with around almost 600,000 of edges, and this may cause. I think that this will be harmful for us when we try to find the attack paths. I can show you the visualize of the sample of sample path attacks. So here's a sample path attacks. So we try to finding the longest length of the attacks in our current data, and here's the process. So we have this graph, basically, and with the longest path, they have the groups going to use software. They have a explanation what is going on into the database, which is really good for the pen tester to understand what is how can they use these techniques to attack to the similar database or similar cybersecurity. And then we also take some points only because this is a lot of points, so it's really confusing. So we just take some random points into our data sets out and try to draw like this. So you can see they all interconnected, and we aim to find the vulnerability, the attack path that the usual hackers can attack into the cybersecurity. And let's go into the multi-agents one. First of all, we will try to set up and import it, every package, and then we will abstractions the relationships from ArangoDB. We will try to fetch owner of the edge and owner of the source and destinations to the edge, and then we will find the paths. So we will find the path starting from the source node and using the breadth first search and finding every path that is possible, and so that is a function for that, but we will use the Gemini to enhance our questions for the user questions. For example, you can see that we are trying to use a different Gemini APIs, and this is a function that will help us to change the API key if there's something errors. And you can see this is a Gemini LLM models. This is the outside Gemini. This is not related to Arangos, but we are two graphs. So this is the first step of using the LLM ArangoDB integration setups, and then this function is used to query the Arango directly with the original questions, and we will use it extract the vulnerability IDs from the AQL's result with the better. This is to extract all of the vulnerability IDs. That is the result from the AQL is coming out. And this is the functions that we will use to create a coup graph from the attack paths that is extracted after you're able to find the paths and output it out and analyze using the coup graph with that. So lastly would be a generate enhancer report. So to show the pen tester how to do the attacks, the same attacks with the same familiar, and how to protect it. This is a main function to process the cybersecurity query using GraphRag and path analysis. You can see that we input as a user questions, and we will try to query each of that with the. We will try to query the user questions and try to find the vulnerabilities, and we will add the abstractions with we will find the vulnerability IDs, and we will start finding paths of that. So after we find a vulnerability, we will find the paths to attack to that vulnerabilities, and then we report to the user afterwards. So this is the two questions that we are coming up, which is how to attack to a corporate laptop that connect via public network. Let's try to run it. So using Gemini and AQL, we can try to make AQL queries to our database, and by using that, we will try to find the vulnerabilities. You can see that we're trying to find the vulnerabilities inside the database, and based on that, we will try the paths of different paths that can attack to this vulnerability according to the AQL. So you can see that they have a lot of vulnerability here. CVE 2024-9404, which is vulnerability IDs from that, and you can see that they can lead to denial of. And yes, so after that, you can see that they explain the analysis, critical vulnerability, what is that, how is critical, severity, scores, and sample attack paths showing that, and afterward you can see that you can have an attack path drawing out so that you can easy to resample that. And not only they have a, so if you check the second questions, you can check the second question, you can see that they are trying to finding the paths, and you have the same three paths, that the most three paths that can attack to the same CPE, and you can based on that and use it to simulate the attack patterns. So that is our project. So thank you for listening.